So guys, today we are going to discuss tangent and normal. So then what the question arises, what is the tangent? Tangent and normal. Let's see this curve and I draw a secant. I draw a secant PQ on this curve and I have to draw a tangent on P at a point P. Then the definition said that let me allow to draw a line PT also. This is the PT line. Then the definition said that if we, as I have to draw a tangent at a point P, then if we move the point Q on the curve towards the P, I am moving the point Q on the curve towards the P. This will be this will form a new line, different new lines. Let's see this. I am moving the point Q on the curve towards the point P. Then what will the tangency of the line PQ? Let's see this. I'm the moving the line. I'm the moving the secant, the line, the secant PQ. Oh, sorry. I am moving the point Q on the curve towards the P. Then what will the tendency of this line? The tendency of this line will be to become the line PT. See this. What will the tendency? It is the PQ line is this. Then it when I move the Q over here, then this line will become here. Then when I move the Q point over here, then this line will become here. Then what is the tendency of the line PQ? The tendency of the line PQ is to become the line PT. Similarly, if I take a point Q dash, let me increase, let me allow to increase this curve in this direction. Okay. Similarly, if I take a secant PQ dash on this curve, and let me allow to draw a PT, sorry, let me allow to draw a PT line over here also, PT dash line. Okay. I named it as the PT dash. Similarly, if I move the point Q dash on the curve towards the P, I am moving this point Q dash on the curve towards the P. Then what will be the tendency of the PQ dash? You can tell that? Yes, you are right, guys. The tendency of the PQ dash will be moving towards the line PT dash. What will the tendency? You can see that I am moving the Q dash point on the curve towards the P. Then what will the tendency? The line is like this. It will moving like this, and it will finally become the line PT dash. So what we can write that if we say that Q tends to P and Q dash tends to P, then from this we can conclude that PQ line will be tends to PT line, and what we can say that PQ dash will tends to PT dash. So we can finally say that TT dash will be tangent of curve at point P. What we can say, as Q tends to P, PQ line tends to PT dash. Sorry, PQ line tends to PT, and as Q dash tends to P, PQ dash will tends to PT dash. So TT dash will be tangent of the curve at a point P. Then write the definition. I'm going to write the mathematical definition of tangent definition. As we have discussed, you can Guess the definition, you can understand what is the tangent is. Then see the tangent to the curve, what we can write, tangent to the curve at a point named as P, at a point P, will be the line whose slope is limit of slope, limit of slope of secant, as I have told that the secant PQ, limit of the slope of secant as Q tends to P, and we have already also taken Q dash tends to P. This is the definition of the tangent. Now take the example to understand it more. Let's take the example. The example is y equals to root mod x. As we have already discussed the graph of this in the functions. Have you remembered? I am going to recall you. I have told you that remember this graph as a shape of bird. Okay, this thing is just for remembering and all. We are talking about y equals to root mod x at a point 0, comma 0, basically origin. See, this is the graph of y equals to root mod x. Okay. And if we talk about the tangent at origin, this is the point O, then what will be the what we have discussed? Then see, I'm going to take a point. I'm going to take a secant O, going to take a secant OA over here, and I have to draw a tangent at a point O. Then move this A on a curve towards O. As I have already discussed in the previous slide, what we have to do? We have to move a point A towards the O on the curve. Then what will the tendency of this line OA? What will the tendency of this line OA will be? The tendency of this line OA will be to become this line. Let's call this line is OT. And what will the tendency? Let's see. This line is OA. Then what will the tendency of this line will be? If I move the point A on the curve, then it will go like this, and it will become a line OT at some point of time when we move the point A much closer to point O, much closer than this point also, much closer than this point, then it become the point OT, sorry, become a line OT. And similarly, I will take a secant on this side also. Let name is B, this OT OB. Then similarly, I will move the point OB on the curve like this. I'm moving the point OB on the I'm moving the point B on the curve towards the O. You can see that if we move it this secant, this line OB on the curve, then what will the tendency of this OB line is? The tendency of you can see that. What will be the tendency? If I take the point B much closer to what's the O on the curve. I am mentioning we have to move the point on the curve, not like this. You are moving like this. You put the point over B over here, or you put the point B over here. We have to move the point on the curve. Okay. If we move the point B on the curve, then what will the tendency of the OB line? You can see this. At some point of time, it become the OT line. Then the OT line, then the OT line is tangent to the curve at point O. And this tangent, this type of tangent at this, as you can see that this is the line which is vertical. This is the vertical line, this is the horizontal line. Then as this is the line which is the vertical, then what we call this? As a vertical tangent. We can name it also, no? Because this line is vertical to the curve, then we can say it, this is the vertical tangent. So we can call it what? Vertical tangent. What we called it? As a vertical tangent. Now move towards the equation of tangent. Now we are going to discuss the equation of tangent. Let's draw a curve. Let's see, this is the, sorry, let me make it re again. This is the curve. And this is our axis. We have to draw a tangent. Let's take a point P at x1 comma y1. Then this will become the tangent of, then this is the tangent. Yes. Perfect. Not perfect. Let's take this again. Yeah. Now it's perfect. I am drawing tangent at a point P. Let's this make theta angle with x-axis. Okay. We are basically discussing the equation of tangent. Equation of tangent. Okay. As we have studied in a straight line, what is the equation of line? We have to need two things to write the equation of line. We have to need slope and we have to need the coordinate, or the we can say the point to write the slope, to write the equation of line. So as we can see that we have the point over here. Okay. So as a point slope format, what is the equation of line will be? Y minus y1 equals to m of x minus x1. This is the point slope form of equation of line. Point slope form of equation line. Okay. Then from this, we can write also, as we also know that basically tan theta equals to dy by dx. You know that? Okay. And dy by dx is also known as m. Basically, what is this? Slope. And this is the quite simple. We have to just substitute the value of m over there as a dy of dx. Then what will be the equation of tangent? Equation of tangent is, we have to do nothing. Y minus y1 equals to, what is the value of m? What we can write the as a m in the instead of m, dy by dx, x minus x1. This is nothing but what? Equation of tangent. Okay, let's discuss the normal over here only. What is the definition of normal? Normal is the line. Normal is the line which is the perpendicular. What? Which will be the perpendicular to the tangent at a point of contact. We have to notice the this is the special point, or you have to note at is you have to listen perfectly. Normal is the line which is the perpendicular. What? Let's draw a line basically which is perpendicular to our tangent. This is our tangent. Let's change the color. Okay, this is line which is perpendicular to our tangent. Let's draw the another line. Oh, let's change the color. Yeah, change it. This, see, this line is also perpendicular to our what? Tangent. This line is also perpendicular to our tangent and also perpendicular. Then which one is the normal? Are all they are normal? Yes or no? No, they not all are the normal. The definition of the normal says the line which is perpendicular to tangent, but at a point of contact on the curve, at a point on which we have drawn the tangent, that calls the point of the contact. Then the definition of normal is the line which is perpendicular to the tangent at a point of contact. Then this is not a normal. This line is also not the normal. This line is also not the normal. The only this line is the normal because it is perpendicular to the tangent, but at the point of contact. Then first, I'm going to write the definition of the normal. What the definition said. Definition. Normal is the line which is perpendicular to tangent at the point of contact. Here we said it P because we have taken the point of contact is P. I'm going to put the point in the box at a point of contact. This is the very important thing. We have to put in the mind always the line which is perpendicular to the tangent, but at the point of contact. This point have to remember to you always. Then let's go back to then what will be the what we will write the equation of the normal. As from this we can see that as the slope of the tangent is we have taken that m. What was that? Dy by dx. And we also know that the slope, the relation of slope of two perpendicular lines. What was that? I'm going to recall you over here only. I denote the slope of tangent. This is slope of tangent. Slope of tangent. And mn as slope of normal. Okay. Let's move this over here. Then, as we can see that both lines are perpendicular, then what is the relation between the two lines which are perpendicular? What are the relations between their slopes? Yes, you are right. MT Mn equals to -1. Then we can say that Mn equals to -1 upon Mt. As we know, the slope of tangent is Mt. Mt is dy by dx. Then what will be the slope of Mn? Let's see. Then we can write that dy by dx into Mn equals to -1. Then Mn will be -1 upon dy by dx from the relation of the lines which are perpendicular. Okay. So we can write the equation of normal also. We have the slope and we have already the point. So the equation of normal will be, okay, equation of normal will be y minus y1 equals to -1 upon, as its slope is -1 upon dy by dx x minus x1. Let's put this also in a box. Let's discuss, let's revise once again. The tangent, the equation of tangent is the point, what we can say that y minus y1 dy by equals to dy by dx x minus x1, and the equation of normal is y minus y1 equals to -1 upon dy by dx x minus x1. You will be more clear when I will discuss the example. Let's take an example. This, yes, as the question. First read the question. The equation of normal to the point, to the curve y equals to x cube minus 2x square plus 4 at a point x equals to 2 is. Basically in this question is we have to find the equation of normal. Then, as we have already discussed, for writing the equation of normal, or we can say that for writing the equation of a line, what we have needed, the two things, the slope and the point. So for this solution, what the curve has given, y equals to x cube minus 2x square plus 4. 2x square plus 4. Okay. This curve has given to us. And we have already given the point x equals to 2. Means if we put the x equals to 2 on this equation, on the curve, the equation on the equation of the curve, then we get the x coordinate basically. Basically, we have to find what? X comma y, point of contact, and the slope of normal. Okay. So first find the point of contact. As x equals to 2 as given, x equals to 2 given in question, given. So put x equals to 2 on the given equation of curve. Okay. Then what will we get? Y equals to, when we put the x equals to 2, then it will become 2 cube. What will be that? 8. Then minus, at x equals to 2, it will become 4. 4 into 2, that will become 8. And then plus 4. Then what we have got? What we have got? We got y equals to 4. Now we have the point. Point is, we have the abscissand ordinate, basically x equals to 2 as given, and we have find to that basically what we have got. This is we got the point. Now our target is to get the slope of the normal. For that, what we have to do? We have to find basically dy by dx. As we all know, the relation between mt and mn equals to, let me write over here. We got the point. We know the relation between mt and mn is basically -1. We know this. We have to use this. Okay. So as the slope, the curve has given y equals to, what was the equation of curve? Y equals to x cube minus 2x square plus 4 plus 4. Then I am going to define dy by dx. What was the that? That was the slope of the tangent. Then dy by dx will be 3x square minus 4x. You have already discussed how to find the differentiation. As I know that I have already taught you how to find the dy by dx. Then this is the slope of tangent. But we have to precisely find the point. We have already given the point x equals to 2. So putting the point on this at x equals to 2, then we get, put the point x equals to 2, then there will be 3 into 4. This will minus 4 into 2. Then what will be there? 12 minus, we will get 12 minus 8 equals to 4. Okay. This we get the dy by dx. This is not the slope of the normal. Don't mistake it. People in hurry put this as the slope of the normal. This is, I am writing over here with the red pen. This is not the slope of normal. Okay. As we know the relation MTMN equals to -1, we get the MT means slope of tangent at the point x equals to 2. What was that? 4 mn equals to -1. Then the mn will be -1 upon 4. Now you can see that we get the slope, and we already got the point over here. So now we are able to write the equation. We are able to write the equation of normal. Then equation of normal is y minus, we got the point. What was the point? 4 equals to -1 upon 4 x minus 2. May simplify it more. What will we become? 4y minus 16 equals to minus x plus 2. Then finally we get 4y plus x equals to 18. This is nothing but This is nothing but the equation of normal. We get the answer. This is our desired answer. Let's discuss further in the next lecture. We will discuss more question on this and discuss further. Thank you.